Mensuration. Mensuration is the part of mathematics that deals in measurement of lengths, areas, volumes of regular as well as irregular figures. So just as these are one-dimensional, then two-dimensional. One-dimensional means we need to find length, then two-dimensional we may find area or perimeter, like that. Then three-dimensional, then volume we can find. So irregular figure we'll discuss about this type of figure. It is bounded by an irregular curve, and this is a straight line, and this is an irregular curve. So we can say it is bounded by an irregular curve and a straight line. So it is, suppose we need to find, say, this it is a river is flowing, then this is the bank, two banks of the river, and this is the river bed. So in this river bed means what? This water. So through this cross section, so water passes, and we can find the volume of water, or to suppose we have to study about the flow of water or current of water, and we need to find cross section of the river. So in this case, this is a straight line and it is bounded by this one. This is the river bed, and then we so our procedure is to measure this type of lengths, this type of ordinates. We say these are ordinates. We can measure at particular point the depth of the river, and with the help of these ordinates we find the area. So this is the figure. It is the baseline. We say this as baseline. This is the irregular curve, and these are the ordinates. So ordinates we require. So we are discussing about Simpson's 1/3 rule. So for Simpson's 1/3 rule, we need odd number of ordinates, y1, y2 up to y twice n plus 1. So this is y1. So our formula is area is given by this common difference. Common difference means this one. In this baseline, we divide it to some divisions. So this is the length of this division. One division, it equal length. So this division. So d is this common difference. We say it common difference. So it will have some value. Then ordinates are this length. From this to this, we are measuring from this point to this point, from this point to this point. So these are ordinates. So if it is y1, then it is y2, and lastly it is y twice n plus 1. So this is the formula. y1, then y. So first ordinate plus last ordinate, then 2 into sum of the remaining odd ordinates, means first one we say y1, then y2, then odd ordinates means y3, y5, etc., and even ordinate means this one. So this is the formula to find the area of irregular figure. So this is an example. So a river is 80 feet wide. So at distance 0. At distance, so it is a bank, one bank. From this point we are starting. Then it is 80 feet wide. So at distance 0, it is ordinate is 0, it is y1. Then at distance 10, ordinate is 40. At distance 20, it is say 75, like this. So we measure these things. So these are the values, and applying this, we have this. So d here is, so this is d, and this d is value is 10. so it is 10 by 3 like this. Similarly, this is number 2. So find Simpson's ruler area of the curvilinear figure. So ordinates are given, so these are yi are given, and base is 150, means it is these are measured from this baseline. It is of distance 150 meter. So means what, y1 is taken here, so 18. So to sum, so this is the irregular curve, say, so this is 18, then after that it at some distance d it is 22, at some distance d it is 26, like this. So this is an irregular figure. So this thing we are to find the area. So these are yi are measured as 18, 22, 26, etc, etc, and d is, so means how many ordinates are there here? 11s are there. 11s are there means there are 10 divisions, so it is 150 by 10, so d is 15. So d is equal to 15. So value here we need to write it is 15. So in this way we need to find, we have to find the area of irregular figure. This is also same thing. River is 10 meter wide, so this one, these are some problems. So offsets are from survey line to a haze. So if we consider this as survey line, so from this we are surveying, so haze is situated here. This is a haze, say some boundary line of some plots, say. So from first it is 0, so this is a point 0, sorry, this is a point 2. At 0 distance it is 2.0, and at distance 6 it is 1.8, at distance 12 it is 3. So means what, d is equal to 6 here, d is equal to 6. So d is equal to 6, then ordinates y1 is 2, this y first and last, so it is 1.2, then y3 is 3, y5 is 3.9, etc, etc. So putting the values we find the area. Similarly this one, so whose base is 146, means it is the baseline. So 146, so we are divide by how many divisions are there, 3, 6. So here 11 ordinates are there, means there are 10 divisions, so it is 14.6. So these are the problems, and we need to find d yi's and then put it to the formula. So these are the sample problems. The next is cuboid. Cuboid means it is a box type. Cuboid means maybe it is a box, or it is a book, or like that. So which has length, breadth and height. So if it is length, then it may be breadth, and this may be height. L, B, H. So volume is L into B into H, and surface area is this one, 2 into LB plus BH plus HL. So this is cuboid. Its diagonal means from this point to this point, this is diagonal. So from this point to this point, so this is the diagonal of this rectangle. This is rectangle actually. If it looks like, say I'm writing here, say so here you see, so this is the diagonal of this front rectangle. Then diagonal of the cuboid is this one, so this plus, so this is the diagonal, so its dimension is ln, this is h, so it is root over, so diagonal is, it is root over, so this value is what, root over l square plus h square. Then again this is right angle triangle, because it is perpendicular to this b, so square of this plus square of this is equal to diagonal. So what we have now, so diagonal is root over square of this is L square plus H square, and square of B is B square. So this is diagonal of the cuboid. This is diagonal of the cuboid. So this thing we should know about the cuboid. So these are some problems. Say we are looking at this. Find the cost of at the rate of 100 per cubic meter digging a pit. So we are digging a pit. So this is a pit 2 by 2 at the top, and its depth is 4. So depth is 4 meter. So this pit we are digging. So volume, our rate is volume per cubic meter rupees 100. So it is cubic meter, it is 4 into 2 into 2, it is 16. So 16 cubic meter into 100, it is rupees 100. So this is equal to rupees 1600. So our cost is rupees 1600. And so how many 3 meter cubes can be cut out from a cuboid? So this is a cuboid. So this is a cuboid 18 by 2 by 9. So we'll cut cube from this 3 meter cube. So this is 18 by 12 by 9. So 18 by 12 by 9. 18 by 12 by 9. So we are cutting out 3 from this. So 3 unit. So 3 by 3 by 3. So from this 18 there are 6 divisions of 3. Here it is, how many it is? 12. So if it is 12, then it is there are 4, and if it is 3, there are 3. Means what? So every side is divisible by 3. So we will do this 18 into 12 into 9 divided by 3 by 3 by 3, 3 by 3 by 3. So it will be 6 into 4 into 3. So answer is 6 into 4 into 3. So 24 into 3, it is 72. So the 72 numbers of cube we can cut from this. A new metal cube is obtained by melting 3 cubes. So 3 cubes means this is size measuring. So 3 cube, this 3 cube, so volume of this is 3 cube, this is 4 cube, this is 5 cube. We add all this, and this will be volume of the new metal cube. So we need to find the dimension of the cube. So sum of this 3 cube plus 4 cube plus 5 cube, and then it will be sum a cube, and we need to find a, the new side of the new cube. So this is all about cube. Then prism and cylinder. So prism, cylinder, they are all of this type. So prism, it has base and it is height. We consider right prism, right cylinder. Right prism, right cylinder means the base are the two, it has two bases, and these two bases, they are parallel, and this edge is perpendicular to the base, means these lateral sides are perpendicular to the base. Similarly, this is this base of this cylinder is circle, and lateral surface, this is the round one, this lateral surface, this is perpendicular to the base. So this is right and regular. Regular means this is a hexagon. So regular means the base is regular. Base is regular means base is a regular figure. So we consider those where base is regular figure. Regular means in case of prism, so sides are equal and angles are equal. So then we have a center of the base. So this is right and regular. So these are the formula. So volume is area of base into height. Then area of lateral surface. Lateral surface means excluding the base, the other surfaces. So this surface we see from the figure. These are some rectangles. These are rectangle with this edge of the base and the height. This is the dimension. So how many bases? This is a hexagon, so there are 6 edges, so it is 6 into 6 times of these rectangles. So this is the lateral surface. Here lateral surface is this, excluding the 2 bases, is the curved surface is the lateral surface. So lateral surface formula is perimeter of the base into height. Here perimeter of the base into height. And whole surface area, obviously we have to add the 2 bases. Then here we see the base of a right prism is an equilateral triangle of side 7 inches and height of the prism is 2 feet. Find the volume of the prism. So equilateral triangle, we should know the area of the, so base. So consider this is triangular prism. So if we imagine this is an irregular equilateral triangle, and its equilateral triangle, and its side is 7 inches and height of the prism is 2 feet. 2 feet means it is 24 inches. So equilateral triangle area is base area is equal to root 3 by, this is the formula, sorry, not root 3 by 4 a square, 7 square. It is the area of the base. It is formula for equilateral triangle, area of equilateral triangle. And height is base area is this, and volume is, so volume is base area into height. So height is, we need to write in terms of inch, so it is 24. So it is root 3 by 4 into 49 into 24. So this is volume number 1. Then number 2, 3, these are all triangular. So this formula is, this is these sides are not equal, sides are different, sides are given. So this formula is s into s minus a into s minus b into s minus c, then take square root. So this is the area of the base. Then the side of triangular prism. So this is also same. Find the volume of the prism and the length of the side of the cube of equal volume. And here we need to find the volume prism. First we have to find the volume of the prism, and then it is length of the side of the cube. So length, so if volume is say, so area, base area is what? Base area is equal to root over what is s here, 25 plus 51 plus 52 divided by 2. It will be how much? 26. It is 52 plus 13. 52 plus 13. It is 52 plus 13. It is 6. 75. 52 plus 13. It is 65. 65 into 65 minus 25. It is 30. Then 40. Sorry, 40. then 65 minus 51 is it is 14, then it is 13. So what will the value? So it is, this is 65 is 13 into 5, and this is 13 into 5, 13 into 5, this is 13, 5 into 8, this is, so what is this? 52 plus, oh no, 52 plus 12, sorry, 52 plus 12, 52 plus 12 is 64. So it is 52 plus 12, it is 64. Then 64 minus 25 is 39. Then 64 minus 52 is 12, it is 12, and 64 minus 51 is 13. So square root will be, there are two 13, 3 into 13, this is 13, then it is 12, 12, it is 3 into 4. So we get 113, then 13, then 4 into 64, 4 into 64, it is 460. So 1414. So this is the area, base area, 13 into 3 into 4 into 4. Then so this base area and height is 60. So height is, so volume is, so volume is 13 into 3 into 4 into 4 into 60. This is the volume, and this is equal to, if it is a cube, this volume, if it is a cube, we have to find this a. It is the volume of the cube, this cube. So this, if it is a cube, then we have to find cubic factorization. So it is 13 into 3, 4, so here 64, 4 into 15 is here, so it is 4 into 15, then 3 4, 1 4 will come out, then 3 into 15, so cube root, so it will be 3. So cube root of this one, so this one, cube root of this one. So 4 will come, but others will not come. So just write cube root of this v. So v is this, it is 1 by, so a is equal to v to the power 1 by 3. This is cube root. So this is the way of finding this. Then next is, say, right prism stands on a triangular base whose sides are 18. So this is the same problem. Then this we see, number 10. A solid iron rectangular block of dimension 4.4 meter. So this is a rectangular block. Rectangular block means it is a cuboid. So this is a cuboid. The whole metal of the cuboid is transformed to a pipe. Means what? First thing we have to find the volume of the cuboid, and then we have to find volume of this, and then we have to see that volume are same, but L is not given. So if we assume L is the length of the pipe, so it is the cylinder. It is a cylinder, hollow cylinder, whose internal radius is 30 and external radius is 35. So L is the length or height of the cylinder, and this should be equal to this one. So let us see. So volume of the cuboid is, so 4.4 meter. So volume is equal to, we write it in terms of centimeter. 440 into 260 into 100. So this is volume. This is volume. With this volume we have to find it. We have to make the pipe. So pipe is this one. This is internal radius is 30 and external radius is 35 because it is thickness 5. So R1 is 30 and R2 is 35. So base area is pi R2 square minus R1 square. So R2 square minus R1 square is pi into 22 by 7 into, this is 35 square, or if we write a plus b whole into a minus b, it is then 65 into 5. So R2 plus R1 into R2 minus R1, it is this one. So this we are writing. Then this is base area. Base area, if height is equal to L, then volume of the cylinder will be, so this V should be equal to L into 22 by 7 into 65 into 5. So how can we find it now? So 5, this is 20 now, 20. Then this will go with 11, it is 2, or 22 it will do. So 22, this is 22, 20. Then 22 into 2, it is 44, it is 0. Then 65, so 13 will go with this. So 13 into 20, this is 13 into 5, 13 into 5, 13 into 5. So 13 will cancel out this. So this 5 will again go with this. This is 4. So what we have now, L is equal to 7 will go to the left hand side. So 7 into 20 into 20, it is 400 into 4. So this centimeter. So is equal to, in meter we divide by 100. So it is 7 into 4 into 4. 7 into 4 into 4. It is meter. So this is the way of solving this type of problems. Next is sphere. Sphere, segment and zone. So this is sphere. If we make the half of this, it will be hemisphere, and if it is not the center of the, so this is center of the sphere. So if it is a hemisphere, then center of the sphere will lie on this, means it is two equal halves. And segment is, it is not in the, it is this, it is distant from the center. And zone is two planes are cutting this sphere parallelly, so this is zone. And for this we write, this is R1, this is H, this is R, this is R, this is R2, this is R1, this is height. And these are the formula. So volume is this, surface area is this. For hemisphere we take the half of this. Then volume of segment, and this is R1, this is R1. Then this R is, this R is this R. radius of the sphere. So volume surface area of the segment or surface area of the zone, it is same value, twice by r h, where r is the radius of the sphere. So these are some problems. So a sphere and a cube have the same surface area. So surface area is same. So sphere surface area is 4 pi r square. This cube has 6a square. Then we have to find the volume. So sphere has surface area S is equal to 4 pi r square, where r is the radius, and cube, for cube it is 6a square. It is the surface area of a cube. Then we can have r square by a square is equal to 6 by 4 pi. So cube times of the cube, volume is so we find now r cube by a cube. So r cube by a cube is, so r cube by a cube is 6 by 4 pi to the power half. First we take the square root and then we take this 3. You need to do with the help of calculator. So find square root of this. This is 2, this is 3. So 3 by 2 pi, or we may write it as pi is, if pi is 22 by 7, then it is 22 by 7, it is 44, then it is 21 to the power. So first take the square root and take the cube. Then how many solid circular cylinder each of length h and diameter 6 can be made out of material of solid sphere? So find the sphere is, it is solid sphere of radius, so this is the solid sphere, it is 6, and from this we need to form some cylinders, so its radius is 3 and height is 8. So we need to find volume of this and n. So volume of this is pi into 9, 3 square is 9, into 8 into n. This should be equal to 4 by 3 pi r, 4 by 3 pi 6 cube. So pi will go, then 4, so this implies n is equal to 4 into 6 cube divided by 3 into 9 into 8. 3 into 9 into 8. So n is this. So it is 4 into 6 cube. So 3. So what n will have? this is 6, this 3 will go so you calculate it, you'll have the value. So n is equal to 4 into 6 cube divided by 3 into 9 into 8. Then next is how many lead balls of quarter of an inch in diameter may be cast out. So it is the same procedure. So n lead balls are made and 3 inch in diameter, supposing no waste. So a ball of 3 inch in diameter, we find the value, the volume of this then its diameter is quarter of 1 by 4 inch. It's the diameter. So radius will be 1 by 8 into 1 by 8 inch. Here radius is 3 by 2 inch. Then you can find the this number of this. So this is the way of finding this. Then this number 4 you can see, number 4 you can see number 4. So it is find how many spherical balls can be obtained by melting a semicircular disc. So semicircular disc, it is a shape is this semicircular disc. So this is a semicircle. So it is the base of the, so this is this means it is of cylindrical shape. So base is a semicircle and height is 7 centimeter diameter. No, this 7 centimeter diameter, it is the base, and 8 millimeter thickness. So height is h is equal to 8 millimeter means 0.8 centimeter and base area is half of pi r square because it is semicircular. So base area is half of pi into 7 square. So volume of the disc is half of 7 square into 0.8, and this is what we have to form spherical ball. So 2.5 mm diameter can be obtained by melting. So 2.5 mm diameter means 0.25 centimeter, because we are doing this in centimeter. It can be obtained by melting. So diameter is this, so radius is half of this, it is 0.125 centimeter, it is radius. So 4 by 3 pi r cube. So volume is 4 by 3 pi then r cube, 0.125 whole cube into n, and this is equal to half of 7 square into 0.8. So this is equal to, this volume is equal to half of 7 square 49 into 0.8. Now we have to find n. So simplify it. half of 49 base area, pi is there. Okay, yes, pi is there. So this pi will go, then remains. So n is equal to, it is 49 into 0.8 into 3. Denominator is 2 into 4 into 0.125 whole cube. So simplify it. We'll have this value for n. So this is the way to solve problems of spheres and this. Then this is a cone. This is a cone. This is a pyramid. So we consider regular. Just in case of cylinder and prism, we consider base as a regular. Base is regular figure. So this is base is circle. In this case, when base is regular, we have this lateral surface as constituents of some equal triangles, equal isosceles triangle. So these are 5 sides in this figure. So it is a pentagon, regular pentagon, and we have, this is the vertex. So we are joining these vertices of the base, and all are equal triangles, and this is isosceles triangle, and the altitude of this altitude of the, so it is isosceles triangle. We have altitude here. So this is altitude. So it is the midpoint joining the vertex and the midpoint. So this altitude, we say this is the slant height of the pyramid. Here in case of cone, circular cone, so from vertex we draw line perpendicular to the base. We can draw it. So the perpendicular means it is the shortest line which can be drawn to the circumference, to the circle. So this is slant height. So this is slant height S. So in case of circular cone, what we have, if we take the cross section, if you see the cross section, so this is the cone. So this is the height, altitude. So this is the center of the base. You join it and you will get this. So this is height, this is radius of the base. So this is S. S is this line S. So what we have, S square, this relation S square is equal to H square plus R square. So if H and R are known, then we can find S. In a similar way, in case of in case of pyramid also, if it is a regular figure, so there is a center here, so this center, so the height, the vertex of the pyramid is perpendicular to this and passes to this point. It is perpendicular to the base. So these are the equal triangles because it is a regular figure, regular polygon. So these are equal triangles. So height is h is perpendicular to this line, perpendicular this point. So the point joining this point and vertex is perpendicular to this triangle, and we can imagine the this as right angle triangle with height as one side, this as one side, and the slant height, because slant height joins this midpoint of the base of the triangle from the vertex. So we need to imagine these things and find the obtain the values with the given clues. So these are the formula. So these are the formula. Is area of base, height, this is volume, is 1/3. Then lateral surface. Lateral surface means excluding the base. This is half. These are only for regular and right. These are all regular and right. Regular and right. And right. Regular means base is a regular figure, and right means the center of the base and vertex. The line segment joining center of the base and vertex is perpendicular to the base. Then slant height. Slant height, if it is for right circular cone, it is slant height, and for right regular pyramid, altitude of the triangular face. So whole surface area is area of the base into area of the lateral surface. So this is about pyramid and cone. And then frustum. So frustum is this. Frustum is we are cutting the cone or pyramid by a plane parallel to the base. So it has two bases. It has two bases. It has two bases. So this is one base. So this is one base and this is one base. Here also two bases. This is one base, this is one base. Then this is a trapezium, because it is regular, so it is trapezium. So this is altitude is the slant height. Here slant height is this one from this point to this point. Then height is distance between the two bases. Here also height is distance between two bases. So these are the values, and these are the formula. So A1 is area of the one base, A2 is area of the other base. Similarly, P1 is perimeter of one base, P2 is perimeter of the second base. Then this is also for R1, R2. Volume is pi h R1, R2. Actually, for some right circular cone, it is A1 is R1 square into pi. A2 is actually this is this root 2 pi R1. So A1 is pi R1 square. So volume will be pi is taken common. Then it is R square. R1 square, R2 square. This is R1, R2. This is wrongly written. So volume is pi h by 3. Then it is R1 square plus R2 square, because it should be area is pi R1 square, and plus R1, R2, not root over. So this is the volume of the frustum. Whole surface area, we add these things, Then these are some problems. So find volume of the frustum of right circular cone, the radii of whose ends are this. These are just applying the formula. Then find amount of water in a bucket in the form of frustum. These are all. So values are given. We just need to put the values to the formula. Then so these are, and you can see this one, number 8. A tent is made in the form of a conic frustum surmounted by a cone. So first thing, when we see these things, so when we have to solve some problems, number 8 say we need to draw this. We are asked to find the canvas, quantity of canvas. So canvas means we need the surface area, measure of the surface area. So tent is like this. First it is a frustum, and then surmounted by a cone. So on this base there is a cone. So two parts are there. So base is 20, and another base is 6. So this is the, and this is 24. Then it is surmounted by a cone. So this height is 4. Base is 3. So R1 is 3. Diameter 6 means radius 3. R2 is 10. So this is 6, this is 10. So consider this triangle. So this is 24, and this one is 10 minus 3. This is 7, because this is 10, this is 3. So this one is 7. So this triangle we need, because we have to find the slant height to find the lateral surface area. So this is 7 square. So S is equal to root over 7 square plus 24 square is equal to 25. So we know the perimeter of the base, we are getting the slant height, so we can find the lateral surface area of the frustum. Now lateral surface area of the cone. So lateral surface area of the cone, it is, height is 4 and this is 3. So this is root over 3 square plus 4 square. So it is equal to 5. So one is 5, other is 25. So this lateral surface is half of P1 plus P2 into slant height, and this surface is half of P1 in half of 3 into slant height. Perimeter is twice by R. So this is perimeter, so it is twice by R is needed. So these are the examples. So this is all. This is required for the mensuration unit. You need to find, you need to know about the plane figures such as hexagon, triangle, etc., ellipse, circle. So you should know about the areas of this. And then, because if base is such a figure for say cone or pyramid or like that, then we need to find this, know the areas. And then this formula, these are important, these are the formula. Then these are the formula for cone and pyramid. This is sphere, zone, etc. So this is prism, cylinder, cuboid, and it is Simpson's rule.